This video is on area polar region. The graph for the equation x to the third minus xy plus y to the third equal to 0 is called this is what the graph looks like. And it's called a Folium of Descartes. In this video, we're going to find the area of this loop right here. And then I will also show that the corresponding polar equation is this right here. And so let's find the corresponding polar equation for this equation here, rectangular equation. Recall that x is r cosine of theta and y is r sine of theta. And then dividing both sides by r squared, then we get r cosine to the third of theta minus cosine theta sine theta, and then r sine to the third of theta equal to 0. And then move this term here to the right side. Divide both sides by cosine to the third of theta plus sine to the third of theta. And we get the corresponding polar equation. And so one more time, this polar equation right here, the graph, is called a Folium of Descartes. And so what we want is the area of this loop right here. So this is the region that we want. And so we need to know the theta values at the pole right here. So it looks like the graph crosses the pole several times. And so to find the theta for the values for the points at the pole, we can set the polar equation here equal to 0. So from here we get sine of theta times cosine of theta equal to 0. And then we know that sine of 0, sine of pi, sine of 2 pi, 3 pi, 4 pi, and so on is 0. And then cosine of pi over 2, of 3 pi over 2, 5 pi over 2, and so on is also 0. So theta can be any of these values right here. And here's a graph again. And then to get this loop right here, I grabbed from theta from pi to 3 pi over 2 to get the loop right here. And so this loop again is part of the graph from theta equal to pi to theta equal to 3 pi over 2. And so the area for this loop here, one more time, the formula is for a polar area of a polar region is 1/2 integral of f of theta squared d theta. So we get the 1/2. And then theta will run from pi to 3 pi over 2. And then f of theta is the function here, and then square it. And now let's find this integral right here. And so first, I'm going to simplify this. So this expression here, this is the same as cosine squared of theta, sine squared of theta, and then the bottom here is squared. And then note that sine of x is tangent of x over secant of x. cosine of x is 1 over secant of x, and then the secant squared is equal to tangent squared of x plus 1. So cosine of squared of theta is 1 over secant squared, and then sine squared of theta is tangent squared of theta over secant squared of theta. Cosine to the third of theta is 1 over secant to the third of theta, and then sine to the third of theta is tangent to the third over secant to the third. The common denominator here is secant to the third, and then we have a power of 2 here. So we can rewrite this as 1 over secant to the 6, and then what's left inside is 1 plus tangent to the third of theta and squared. And then now multiply the top by secant to the fourth, and then multiply the bottom by secant to the fourth. And then what's left on the top is just tangent squared, and what's left here is 1 over secant squared. And then we can move which we can rewrite as secant squared. So this expression right here is the same as secant squared of theta times tangent squared of theta, dividing by 1 plus tangent to the third of theta squared. So here's our integral, and then we end up with this. And then from here, let u be tangent of theta. Then recall that the derivative tangent is secant squared. So du d theta is secant squared theta. And then we have du is secant squared theta times d theta. So the integral becomes the integral of u squared, tangent is u, dividing by 1 plus u to the third squared. Secant squared theta d theta is just du. And then we need to do one more substitution. So let v be 1 plus u to the third. dv du will be 3u squared. So we get 1/3 dv is u squared du. So this integral here becomes 1/3 dv because u squared du is 1/3 dv. 1 plus u to the third is just v, and then we have v squared. And then we can rewrite this as 1/3 times the integral of v to the negative 2. The integral of v to the negative 2 is negative 1 over v. So we end up with negative 1 over 3 times 1 plus u to the third. Okay, that's what v is. But u is tangent of theta. So we get negative 1 over 3 times 1 plus tangent to the third of theta. So our original integral right here, which is the area of the region inside the loop. So this expression becomes this. But the problem, and then we need to evaluate, go evaluate from theta runs from pi to 3 pi over 2. The problem here is tangent of 3 pi over 2 is undefined. So we have an improper integral. So we can rewrite this as 1/2 times the limit of this integral here, and as from pi to c, as c approaches 3 pi over 2 from the left. And then a few moments ago, we worked this out, and the integral here comes equal to -1 over 3 times 1 plus tangent to the third theta. And then evaluating from pi to c. So when theta is c, then we get -1 over 3 times tangent to the third of c. When theta is pi, tangent of pi is 0, so we just get -1/3. This becomes plus 1/3. And then notice that the limit of tangent to the third of c as c approaches 3 pi over 2 from the left is positive infinity. And then let's look at the graph of tangent to the third of x. This is the vertical line x equal to pi. And then this is the vertical line x equal to 3 pi over 2. And then as we can see that as x approaches 3 pi over 2 from the left, we can see that tangent approaches infinity. So this part here will go to infinity as c approaches 3 pi over 2 from the left. So this quantity here will approach 0. And so what's left is just the 1/3. So we get 1/2 times 1/3, which is 1/6. And so in summary, the area of this loop right here, the region inside this loop of this Folium of Descartes, is 1/6. And that's the end of the video.